Okay, let's talk about colligative properties. The properties of a solution differ from those of the pure solvent. The colligative properties of solutions are those properties that depend on the number of particles dissolved in solution rather than their nature. These properties include vapor pressure lowering, freezing point depression, boiling point elevation, osmotic pressure. The vapor pressure of a liquid is the pressure of the gas above the liquid. Now right now we're talking about vapor pressure lowering, and we're talking about non-volatile solids. The vapor pressure is a colligative property that decreases by the addition of a non-volatile solid. The vapor pressure of the solution, your non-volatile solute, in non-electrolyte solvent will be lower than the vapor pressure of the pure solvent. Vapor pressure lowering is independent of the nature of the solid, but directly proportional to its concentration. So it doesn't matter what the species is, but it does matter on the concentration of that species and how many of those solute particles are present. Any interference with the ability of solvent particles to vaporize results in a decrease in gas molecules and hence a lower vapor pressure. Adding a non-volatile solute to the solution decreases the surface area formerly occupied by just solvent. Now you have a mixture of solute and solvent particles on the surface. So what you had if you have a pure solvent is all the surface of that liquid is all solvent molecules. When you have a solute being added to it, now you have a homogeneous solution, so you have solute and solvent particles on that surface of the water. And what happens is it diminishes the rate of vaporization of that solvent. Hence, there will be a lower vapor pressure compared to the pure solvent. It's going to be a lot harder for that liquid to change into a gas because the paths on that surface of the liquid now have solute particles in the way. So you're going to have less solvent being able to change from a liquid to a gas on the surface. Raoult's law states that the vapor pressure of a solution containing a non-electrolyte, non-volatile solute is proportional to the mole fraction of the solvent. P solution is equal to P superscript 0 solvent times the mole fraction of solvent, where P solution is the vapor pressure of your solution, that is your mixture of your solute and solvent. Chi solvent is the mole fraction of your solvent, and P naught solvent is the pure vapor pressure of the solvent. So basically your vapor pressure of the solution, meaning your solute and solvent, will be a fraction of that of your pure solvent. And it depends on how much solvent is present. Basically the vapor pressure solution is a fraction of that of the pure solvent and depends on the percentage of the solvent making up the solution. That partial pressure, the partial vapor pressure of that solvent. If a solution contains a volatile solute, so now we're talking about volatile, the vapor pressure of the solution will be a combination of the partial vapor pressures of each volatile component. So what happens is you get P solution is equal to your vapor pressure of your solvent times your mole fraction of solvent. That part of the solvent is contributing to the vapor pressure of the solution, plus the vapor pressure of your solute, that mole fraction of the solute times its pure vapor pressure of the solid. Homework 72.